Hello friends, welcome to Transverse Academy. In this particular lecture, we will discuss about the radial and the transverse velocities. So what is the radial velocity? So radial velocity is the velocity along the radial direction, and the velocity perpendicular to the radial direction is transverse velocity. So radial velocity is along the radius vector. Okay, so suppose let us consider a curve here. Okay, and there is a point P on this curve, and let us assume the coordinates as r theta, and this is our pole. O is our pole. Okay, so the OP vector, this is our OP vector. OP vector is the radius vector. So the direction along the radius vector, So this is the direction along the radius vector. So the direction along the radius vector is radial direction. And the direction perpendicular to the radial direction is transverse direction. This is transverse direction. Okay, so let us consider the unit vector along the radial direction as ER and the unit vector along the transverse direction is E theta. Okay, so the radial direction is along the radius vector and transverse direction is perpendicular to the direction of the radius vector. Okay, so what will be the velocity along the radial direction? It will be radial velocity. And what will be the acceleration along the radial direction? Radial acceleration. Similarly, what will be the velocity perpendicular to the radius vector? This is transverse velocity. And similarly, acceleration perpendicular to the radius vector is transverse acceleration. Okay, so let us write down the statement here. So we have the unit vector along radius vector is equal to ER, and unit vector perpendicular to radius vector is E theta. Okay, so this is the unit vector along the radius vector, and unit vector perpendicular to radius vector is E theta. So let us remember a relation between ER and E theta. Okay, so on differentiating ER, we get d upon dt of ER is equal to d theta upon dt into E theta, and d upon dt of E theta is equal to minus d theta upon dt into ER. Let us remember this. So I will write down this expression. So we have d upon dt of ER is equal to d theta upon dt into E theta, and d upon dt of E theta is equal to minus d theta upon dt into ER. Okay, so let us proceed for the derivation of expression for the velocity. Okay, so how we find the unit vector? Suppose our vector is this OP. Okay, so the unit vector OP. Okay, unit vector along OP, that is OP, is equal to OP vector upon magnitude of OP vector. So this is equal to, so radius vector is R vector, and this distance is R. This will be equal to R vector upon R. And what is the unit vector along the radial direction is ER. This is equal to ER. So R vector is equal to R into ER. Okay, so let us read the statement. But we are having the resolved parts of the velocity at P. So let us consider the velocity at P is V. The velocity at P is equal to V. So the resolved part of V along radial direction and perpendicular. Along radial we mean along the radius vector. Perpendicular to radial direction. Is equal to radial velocity. And this is perpendicular to radial direction is transverse velocity. Similarly, resolved part of acceleration along radial or दूसरा perpendicular to radial direction is equal to radial acceleration, and this is transverse acceleration. Okay, so we have velocity is equal to d upon dt of position vector, and position vector we can write as r dot er. This is d upon dt of r dot. Okay, so let us expand this. So we have this as r into d of dt of ER plus ER into dr upon dt. Okay, and let us use this expression. So we have d upon dt of ER, this expression. Let us further simplify this. So we have velocity vector is equal to dr upon dt is equal to r into der upon dt is equal to d theta upon dt into e theta plus dr upon dt into er. Okay, so this is our er into r d theta upon dt, and this is dr upon dt. So dr upon dt is this radial. So let us write one step further. So this is equal to dr upon dt into er is plus r d theta upon dt into e theta. Okay. Okay. So this is our radial velocity. Radial velocity. And r d theta upon dt is transverse velocity. This is unit vector perpendicular to radius vector, and this is unit vector. Sorry, er is the this is er is the unit vector, unit vector, unit vector along radius vector. Radius vector. By along radius vector we mean radial direction. Okay. So let us proceed for finding the acceleration. So what we are having is that acceleration is given by dv upon dt. So this is equal to d upon dt of what is our velocity vector? So this is radial velocity. So dr upon dt into er plus this is unit vector along radial direction r d theta upon dt. This is the velocity along the transverse direction into unit vector along the transverse direction e theta. Okay. So let us differentiate this by parts. So this is equal to let us move in this particular direction. So this is dr upon dt into d of dt of er plus er into d2r upon dt plus r d theta upon dt into d of dt of e theta plus r into d2 theta upon dt square into e theta plus dr upon dt into d theta upon dt into e theta. Okay, this is okay. So this is the differentiation of this particular term, and this is different. This is differentiation of this particular term. Okay, so let us further simplify it. So we have let us put the value of d upon dt of er. So dr upon dt into d theta upon dt into e theta. Okay, plus er into d2r upon dt plus r d theta upon dt into minus of this is minus d theta upon dt into er plus r d2 theta upon dt square into e theta plus dr upon dt into d theta upon dt into e theta. So this is equal to, so this we can this is d theta upon dt ka whole square. So let us put er term at a particular place. So we have this as d2r upon dt square minus r d theta upon dt whole square into er. Okay, plus this is equal to so dr upon dt into d theta upon dt. This is dr upon dt into d theta upon dt, and we have this as r dt. So this is r d2 theta upon dt square plus 2 times of dr upon dt into d theta upon dt into e theta. Okay, so this is the term of e theta. This is the term of e theta, and this is the term of e theta. Okay, so let us we have combined all these things. Okay, so this is same. dr upon dt and d theta upon dt. So this will be 2 times of dr upon dt, d theta upon dt. Let us further simplify this. So the acceleration we are getting is this is equal to d2r upon dt square minus r d theta upon dt ka whole square. This is er plus this we can write it as 1 upon r d upon dt of r square d theta upon dt. Okay, if you differentiate this, we will get this particular expression. This is equal to 1 upon r d upon dt r square d theta upon dt. This is along the transverse direction. Okay, so this is our acceleration along radius vector, that is radial acceleration, and this is acceleration perpendicular to radius vector, radius vector is op vector, that is r vector, radius vector is op vector. Along the radius vector, radial acceleration, and perpendicular to radius vector is transverse acceleration. And what we have derived for the velocity is equal to dr upon dt into er plus r d theta upon dt into e theta. Okay, so we have this as radial velocity and this as transverse velocity. This is radial velocity and this is transverse velocity. Okay, so we will discuss problems on this topic of radial and transverse velocities and radial and transverse acceleration in next particular lecture. Thank you.